Welcome to Narendra Academy, and I am Narendra Kumar, and we are going to start our playlist called Physics Concepts Made Simple. So, physics is one subject which many people find a little difficult, and it is difficult. It is not literally easy, but it is not easy, but it is simple. So, there is a difference between the word easy and the word simple. If you understand something clearly, you get the concept exactly, then it is simple. So, no good teacher would say that something is beyond a student. No good teacher would say that. A subject can't be beyond you. It is within you, but it requires a certain conceptual understanding. You have to understand exactly the concept. So, what we'll do is we'll make physics made simple by breaking down the whole thing into small parts, small digestible parts, and each part would be so simple, so nice, so that you can slowly add up all the parts and get that beautiful whole that is physics. Now, physics has very broad divisions. Like today, we'll do the mechanics. So, we'll start with mechanics. It's usually the first broad unit. In mechanics, our lesson today is rest, motion, distance, displacement. Rest, motion, distance and displacement. We simply have to understand these four concepts. Rest. So, let me take this thing, and this is at rest. We say this is at rest. Why do we say that this is at rest? This is at rest. Why do we say that this is at rest? We say this is at rest. I am at rest. This board is at rest. We say that. We say because a normal person would say it is at rest. What is there to say anything about that? But there is a small subtle concept here. This we say is at rest because the wall is at rest. This city is at rest. I mean, the whole ground is at rest. Something is at rest in relation to which this board and this thing is at rest. If something is at rest, this is at rest in relation to that, and again that we can make it precise. This does not change its position with respect to a certain, let's call it a point or a line, or actually in physics they say axis. So, you have what is called the concept of reference frame. Now, we don't have to make a big issue about reference frame. It is simply a three-dimensional frame. So, anything is three-dimensional, a room, let's say. So, with respect to that, that frame is at rest, and this is at rest with respect to that frame, reference frame. Now, this seems quite simple only, but it has a very interesting application. Suppose you are going in a train and it's closed all around. So, you are also at rest with respect to whom? With respect to maybe the chairs there. So, you are at rest with respect to the chair. The train is moving, uniformly it's moving. And your closed train, you won't even know if the train doesn't accelerate. You won't even know that you are moving if it's moving very smoothly. So, you will say that I am at rest, but then you open the window and you see outside with respect to a tree, let's say, you are changing your position and you are in motion. See how interesting it is. So, it is always rest and motion, in a manner of speaking, are not absolute. I mean, this is a very confusing word, absolute. Like there is an absolute rest, because rest is with respect to a reference frame which is at rest. And with respect to that, you are not changing your position. So, you are where you are, that is rest. So, rest is where you are with respect to a reference frame. Motion is when you are changing your reference frame. So, obviously, we can have a reference frame like this. This is the x-axis, this is the y-axis, and let's say this is a three-dimensional thing. So, let's make it two-dimensional just for the clarity. So, this body A, point, we can call it like a point mass. Point is at rest because its distance from here to here, or here to here and here to here, its coordinates. This is the y coordinate and this is the x coordinate. These x and y coordinates of this point A is not changing, then we call it at rest. But suppose this A moved, it moved here, and now this was x1, y1, this x2, y2, obviously it has changed its coordinates from x1 to x2, and it has changed its coordinates from y1 to y2. So we say it has moved. You know, someone listening to this might be wondering, I mean, it's so simple, rest, motion, why such complications? You will understand slowly why in physics we talk very precisely about direction, about, you know, holding it, fixing it. And that is the beauty of physics when you start connecting it to maths. So this is very clear. I think we got the concept that rest and motion. Rest is not changing the position with respect to the reference frame, and motion is changing your position both in the x and y. It can even be only in the x direction, only in the y direction, all that. But it changes its position with respect to a reference frame. So it can be even 3D, like it can be here. So it can move like this. So its z coordinate also will come. That's okay. I think we all got the concept of rest and motion. Now we have got two different concepts, distance and displacement, which we'll do in the next lesson. Thank you so much. This is Narendra Kumar, and we'll meet next in the lesson distance and displacement, which is a very beautiful concept. Again, a simple concept, not easy concept, but simple concept indeed. Thank you so much.